marks. Your annual examination point of view. Now see this one. That is the list of the chapters. Open and sound. Now there are some parts like production of the sound, propagation of sound, characteristics of sound. So first we discuss the production of sound. How the sounds are produced. See, that is how the sound is produced. Here some videos are there, just you see. See. These are the waves, different types of waves.
Wasn't that wonderful? Let's check out how this music was produced. Click on an instrument to see how it works.
That is, there are three types of instruments.
Wasn't that wonderful? Let's check out how this music was produced. Click on an instrument to see how it works.
See, you know very well. Use the assembly.
The drum is a percussion instrument.
That is the drum.
In percussion instruments, vibrations are produced by striking two things together. In the case of the drum, the stretched drum membrane, when struck, vibrates to produce sound.
That is, stretched drum membrane vibrates. Now then the sound is produced like a vibration.
In all the examples we just saw, sound is produced by vibrating objects.
That is the plug
In
which
fact,
vibrates.
any sound you hear, let's say a bell ringing,
Drum membrane,
a bee buzzing,
air column
or a
vibrates
dog barking,
like a
is a
donkey.
result of something vibrating.
Metal vibrates.
So, vibrations are responsible for the production of sound.
Vibrate. Okay. So now that is the concept behind it. How the sound produced. Now that you know, the sound we hear from the musical instrument is not just the result of the vibration of the strings or membranes. The entire instrument vibrates to produce the music we hear. That is the part of the vibrations, membranes, okay, strings. Now see the next.
Now that you're familiar with the different types of instruments and their vibrating parts, here's a small activity for you. Drag and drop the instruments in the appropriate categories.
So now just tell me, in first, that is particular instrument is what? Triangular. Okay. Okay, this is cymbals. Now in wind instruments. Very good. Just drag it B. Saxophone. And last that is the red put here and harp. Now just we see what is the
Well done. The cymbals and the triangle are percussion instruments as they produce sound when two surfaces strike each other. The beam and the saxophone are wind instruments as their vibrating air columns produce sound. The violin and the harp are string instruments as they are played by blowing or plucking their strings.
Are string instruments or they are played by the blowing or the plucking their strings. Now see, excellent performance. That is the video. Vibration of the sound. How the sound
The
vibrates.
sounds we hear are actually vibrations that begin when an object produces a sound.
Before this, just see. Sound here are what is the sound? Sound means sensation of hearing. The meaning of the sound is what? That is sensation of hearing. Just we hear the sound. Now sound is required the medium. What is the required means? We can say sound required a medium. If medium are there, then sound is produced, sound is generated. There are two types of medium. That is, first one is what? That is transverse. We can say that is the transverse wave. Another one is, second one, that is longitudinal wave. Longitudinal wave. The difference transverse and longitudinal, any idea? Transverse is perpendicular to the motion. It means what we can say, what is the transverse wave? Is sounds traveling perpendicular to the motion. Means suppose see here, that is the motion is there, that is perpendicular, creating the angle 90 degree. That is what? Sound travels in transverse in nature, transverse wave in nature. This is the example of this one. Now second one, that is longitudinal. Longitudinal means that is parallel to the horizontal surface. See, suppose here see, this is the traveling of sound, that is the motion. Sound is also traveling in the horizontal way, or we can say that is parallel to the motion. Parallel to the motion. That is coming as the longitudinal. There are two types of wave. So now just see this video related to this one.
Sound and then continues moving through matter.
Vibrations are generated.
The
That
tuning
is the
fork,
fork tube.
a two-branched metal tool used for tuning musical
If you
instruments.
just put here, that is
And
vibrations
use
are
sound
generated.
waves.
Okay, that is the fork tube.
If we gently strike a tuning fork with a rubber mallet, we will hear the
This is
sound it
indicating the
produces,
vibrations.
even though we can't
These
see
are
the sound
indicating the
vibrations
vibration of the sound.
or the sound waves as they travel through the air. Let's perform an experiment which will allow us to see the sound vibrations as they travel through a medium. For this experiment, we will need a tuning fork, a rubber mallet, and a white container of water. First, we will
See,
place a
very easy
container of water
example.
on the
See how the
table,
sounds propagate in
giving
the
it time to
medium.
become
Okay,
completely still.
that is.
Use the rubber mallet to strike the tuning fork and then insert it about 2 inches into the water. As you do this, you can watch the vibrations of the
The water
fork create
surface, water
ripples
layer.
that are moving through the water away from
That is
the
the
fork.
waves propagate in the horizontal
Now
wave.
let's look
That is.
more closely at what actually was happening when the vibrating fork was immersed. When the tuning fork struck the surface, water molecules bounced off the fork because of its vibrations.
Due to the vibrations. That is the reason.
The vibrations of the
That
molecules
is the
raised the
vibrations.
fork,
Layers are moving up and
Then
down. That is
vibrated
the part of the vibrations.
which in turn vibrated the molecules next to them. In this way, the vibrations
This tuning fork inside the water, and this water layers are changed due to the vibrations. That is the figure. That is the example of the figure how the vibrations occurs in the water layer. So see this one. Some molecules are there. That is the intermolecular forces are there.
move
That's the
through the water in
intermolecular
the form
forces of the
ripples
atoms of the
until they
molecule
reach the
inside the
other
water.
container. In a vacuum, there will be no molecules or particles for sound vibrations to move through. That means that sound cannot travel through a vacuum. From this experiment, we can see how sound travels in the form of waves through a medium. Summary. Sound is what is produced by the vibration of particles or molecules through a particular medium. Sound cannot travel in a vacuum.
Got it? Sound travels only in the medium. Medium is required, not travel in the vacuum. Okay? Next one, see. This is the activity part. Top here means liquid and vacuums are there. Suppose this means Do this one.
Excellent.
Vibrations are there. In vacuum, there is no any vibration. Okay, just see. One activity here related to vacuum.
Excellent.
See, no vibrations are there. Just you see both the figures. What is the difference between this figure and this figure? So vacuum, see, there is no any propagation of vibrations are there. No layer generated. But in the water, liquid, if we just put down the rubber inside the liquid, vibrations are there. Waves are there. Okay. Now next part. See, that is the PPT of the sounds, power presentation of the sound and the vibration. Here, this is the sound. Wave sounds cannot travel through in the vacuum. Vibrations of the particle, if we strike the fork tube, that is some vibrations are generated. That is the medium is required. That is the tuning fork. See, the vibrations are there, just moving. That is in the front of this one. That is the vibrations of the propagation of sound. Here the examples are there. See, so many examples are there related to the sound and the vibration. That is the first one. Requirements. What is the required? How the sound generated waves are propagated in the one medium to another medium. Means fill the container with the water. That is okay. Use the rubber metal and seal the tuning fork. Seal the tuning fork, vibrations are generated. That is the example of the sound and the vibrations. Now see the next one. Rubber metal, white container of water. Again, you just see the previous activity related to this one. Then creating ripples moving through the water away from the fork. That is the observation. What is the observation? Suppose tuning fork and the vibration rubber material you put inside the water, then what happened? Yes. Creating vibrations, propagation of the waves, generating the waves, generating the propagation of the sounds. Got it? Now see the next. That is the sound. A type of longitudinal waves that originated as the vibration of the medium. It can be heard by the human. Now for vacuum, a region in which there are no molecules. Since vacuum is what? That is the vacuum. There is no any atoms, no any molecules surrounding by there. So we cannot listen the sounds, cannot propagate the sounds. Okay. Vibrations require a medium. Require a medium. See, the to and flow motion of the body about the main position is here. Just you split it. That is what vibrations are generated. What is that? Is the vibrations. Tuning fork. A small two-prong long metal devices that can be stuck produce a mixed pitches used as a reference. So what term is their pitches? Pitch. What is the pitch? Any idea? Pitch. See, that is the pitch. Pitch, there are two types. First, compression, another one is rarefaction. Compression, another one is rarefaction. Compression is you speak very loud. बहुत तेज आवाज आ रहा है. Means what? That is the compression. If you see the graph, that is compression. That is the graph creating a lot of noise. That is the compression. Okay. Now in rarefaction is what? Relax mode. Understand the terms? Compression and rarefaction. Where is one is relax mode. If anyone is answer like this, yeah, that is relax mode. That is going to be the rarefaction and compression. That is very high pitches. यहाँ पे is where in compression very high pitches. Very high pitches. Here that is low pitch. What is the concept of pitch? Well, now see, next part. propagation of sound. First we discuss that is the production of the sound. Now second one next we see that is what is the propagation of sound. Medium is required or not? We see. DJ sound. No value. These all are the different type of pitches. That is the pitches. Compression and rear.
We hear so many sounds around us. Some of them are louder than the others, and some of them are shriller. Have you ever wondered why? Let's find out with an experiment.
See, the experiment related to
Take a
different type
rubber
of
band
voice.
and keeping one of its ends fixed, stretch it a little.
That is, spread the rubber.
Now, plug it and listen to the sound carefully.
Vibrations are there.
Next, stretch it further and plug it again.
Pitches are changed.
Doesn't it sound different this time? When the rubber band is stretched lightly and plugged, it shows less number of vibrations per unit time. That is, less number of compressions and rarefactions pass a fixed point per unit time. This means that the sound produced has a low frequency and it is sensed as a low-pitched sound.
Low pitch, low frequency.
But when the rubber band is stretched harder and plugged, it shows more number of vibrations per
Very
unit
fast.
time.
Moving very fast.
That is, a higher number of compressions and rarefactions pass a fixed point per unit time. This means that the sound produced has a higher frequency and it is sensed as a high-pitched sound. Let's represent these sound waves graphically. Compression is represented by a peak called the crest of the wave. And
See here, that is the crest and graph. There are some different types of important points related to this graph. That is the pressure. Moving this one, that is what amplitude. This one is known as the amplitude. Now that is the trough. Downward below this axis, below the time, that is the trough. And this one above this one, that is the crest. The gap between one crest to another crest, that is known as the wavelength. Lambda denoted by the Greek word. This is the wavelength. Now the maximum height cover, that is known as the amplitude. A. This one means here to here, that is A. Okay? Now
Fraction is represented by a value called the trough. Here the change in pressure from the maximum value to the minimum value and again to the maximum value is one complete oscillation.
up and down.
The number of such oscillations per unit time gives the frequency. From the graphs, we can clearly see that the frequency of sound from the rubber band stretched harder is higher. Now, let's do this experiment a bit differently. Stretch the rubber band, plug it gently, and listen to the sound. Next, plug the stretched rubber band strongly and listen to the sound.
Here both the sound, there are
Isn't
different
the
sounds
sound
out there.
louder this time? When you plug the rubber band gently, the force applied is small and this produces sound waves with low energy. These waves have small amplitude. That is, the particles in the medium are displaced only a short distance from their
Very
original
small,
position.
close to each other.
Small amplitude results in a sound with low volume. When you pluck the rubber band strongly, the force applied is greater, and this produces sound waves of high energy. These waves have large amplitude. That is, the particles in the medium are displaced a greater distance from their original position. Large amplitude results in a sound with high volume.
That is the softness and loudness. That is depend on the term of the amplitude.
Let's represent these sound waves graphically and indicate their amplitudes.
This maximum height.
The amplitude of a sound wave is the magnitude of change in pressure from the mean value. Here we can clearly see that the amplitude of the sound on the rubber band plucked strongly is larger.
Louder, high pitches, high frequency. Here the figure, this one, that is the graph of this one, that is related to the amplitude. Maximum height covering from this one, that is the maximum amplitude. High frequency, or we can say that is including the high pitches. Okay. Now next see. That is the related to the problem. String 1 and string 2. We can say that is the problem. Like this one is identified, that is the waveform A, that is waveform B. Now here what? Which one is the compression? Which one is the rarefaction? Which one? This is the rarefaction. That is rarefaction. Means here the medium of the amplitudes are smallest compared to this thing. That is the wavelength. Now here that is very large. The concept of the next one see. Pitches and loudness of the sound. Different type of sound of different type of pitch.
A sound is characterized by its pitch and loudness. We know that the pitch of a sound is related to its frequency, and the loudness of the sound is determined by its amplitude. Now, let's have some fun exploring different musical instruments to hear their sounds. Click on a musical instrument to explore it.
See.
Select the length of the string and click pluck gently or pluck strongly to hear the sound and see the wave shape.
See now there this is the one length of the string short and another very length of the string that is long. Different type of sounds are there. See, different are there, stronger, louder. That is the pitches. Got it? Jal color, half and full. If half is there, then what type of sound arises? Now if full are there now, that is what type of sound arises. Like a mobile machine. What the concept behind it? Yes. Now that is true. For short and long, for short. Strong. Different
We compare wave shapes to compare the different wave shapes.
Now, these are the points of the remember. A sound is a characteristic by the pitch and loudness. You know very well. Pitches of the sound is related to its frequency. Higher frequency, lower frequency. If frequencies are more, we can say that is the high pitches. If the frequencies are low, we can say that is the low pitches. Loudness of the sound is determined by its amplitude. If amplitude are maximum, the sound is moving at the maximum part. Okay, that is the amplitude. Now to the next part. Movement of the particles. How the particles are moved. This is the video just to see. Different type of sounds arising.
We hear sounds all day, but have you ever wondered how we hear them? Let's find out. How about taking the example of gong? When the beater strikes the gong vibrates.
Vibrations.
When it vibrates, it disturbs the surrounding air particles. Place the magnifier over the air particles to have a closer look at them. The air particles will not disturb the neighboring particles and come back to their original position. Now, the disturbed air particles further displace the particles.
That disturbance creates, that is the wave particle.
This process
All these are
continues till the
just
sound
one another.
reaches the ear. Did you notice that the air particles do not travel all the way from the gong to the ear? Only the disturbance created by the vibrating gong travels through the air particles. Now,
Strong
let's
vibrations
look
are there,
at
we
the
use
use.
strong sounds are listening.
When the vibrating gong moves forward and hits the nearest air
Very
particles,
slow motion.
it actually compresses the surrounding air, creating a high pressure region called
That
compression.
is compression. High pressure.
And when the vibrating gong moves backwards, the compressed air spreads out and a low pressure region called rarefaction is created. As the gong moves back and forth, a series of compressions and rarefactions is created. This is how sound waves are produced.
What is this figure? That is the figure
So
representing
what
the
can we
rarefaction
say
and the
based on this? Sound is transmitted by pressure variations or density variations in room.
different type of particles close to very close to each other. That is the high detail. Detail, that is a part of the compression. See the next one. This is not related to you. Another one, that is the visual related to this one.
Propagation of sound.
Propagation of the sound in a different medium. Means air medium, laser medium, air medium, whatever mediums are there.
When we strike the bell, it will begin vibrating. These
Vibrations are good, vibration
to
indicate
the nearby air molecules.
the radiation and compression and sound
Molecules to vibrate, which in turn will cause their nearby molecules to vibrate. In this way, the vibrations will spread out from the bell in the form of waves.
that is the way.
If we happen to be in the range of these waves, we hear the sound emanating from the bell. Meanwhile, the sound waves continue spreading out until they lose their energy. Sound requires a medium to travel through. Meaning, molecules or particles
The vibration, that's the way.
sound wave. The vacuum of outer space has no
Vacuum,
molecules.
okay, that is the medium. Means sound requires a medium for propagating.
The propagation of sound won't be the same in all media. Let's look at this by comparing how sound propagates through gases, liquids, and solids. In a gaseous medium,
Any mediums are required, like solid, gaseous, and all these are the part of the rarefaction and the compression. Okay,
cause vibrations in the surrounding
that is the amplitude. All these are moving around
means the sound waves will require much less time as vibrations.
Propagation of the sound one medium to another medium. Air medium to laser medium. That is more to this one. Or always never in straight line.
Sound will travel in slow waves.
Yes.
And
And different gas.
sound waves.
That is the air section. This one is part of the temperature.
Sound implies
Now that is something related to this one. Propagation of sound.
propagate.
Sound travels in the form of the waves. So very well. That requires a medium to propagate, not in vacuum. The next one. This is the concept that see, propagation of sound in a different media, in gaseous state, in liquid, out here in solid. There are different type of parts in the environment present like the solid, liquid and gas. In gaseous what is the molecules are arranged apart, propagate of sound one medium to another medium, that is we can say that is randomized to each other, crossing to each other. Now that is the cause moving the particles very slow in the gaseous state, in liquid form propagate very slowly, like that we can say that the real factor is there. Okay, that is molecular forces are very close to each other. Okay, now here in solid form molecules close back. This is the upper very high and propagate the sound. Got it? Now see the next. In solid, liquid and gases, the activity is, suppose we drag this one, solid is what? We drag here. Okay, got it? Here, no. This one, no. This solid is here, we got like this one. That is depending on these cases, the air vacuum and the temperature. Now in solid is what?